In this video, we're going to go through a couple of examples of how we're going to use information about the function to form an equation for an exponential function. So in this example, the information that they're telling us is that it passes through the 2 points, 0, 3, and 3, 192. So we're going to start off, I'm going to write this in general form. Y is equal to a times b to the x. Now, I need to find, in order to put this in exponential form, I need to find my a and my b, okay? So in this problem, they actually indirectly give me my value of a. So if you notice, they give me this point here, 0, 3. 0, 3 is the y-intercept because it's the value of y when x is 0. And we said that our value of a is the y-intercept. So indirectly, they told us what the value of a is. The value of a is 3. So all we have left to do now is figure out our value of b. And we can do that by using the second point that they give us. So I'm going to plug in 3 for x and 192 for y. So I'm plugging in 3 for x and 192 for y, and then I'm going to go ahead and solve b from here. So the first thing I need to do is divide both sides by 3. So that gives me, I'll finish it up here. If I divide both sides by 3, I'm going to take 192 divided by 3. That's going to give me 64 is equal to b to the third. Now to solve for b, I'm going to take the cubed root of both sides. So that leaves me with b is equal to 4. So now I have my a and my b, and I can write my final answer as 3 times 4 to the x. So this is my growth factor, my b, and because it's greater than 1, I know it's increasing. And this is my y-intercept, which they gave that to us in the problem. Okay, in the second example, there's a little bit more work involved in this one because they don't give us our value of a. So it's a little bit more work. If you notice, we don't have the y-intercept here because we don't have the point in which we have 0 for x and some other value for y. So when we have that case, what we have to do is set up 2 different equations, and we're going to have a system of equations of 2 unknowns. So I'm going to make equation 1 with this point. So I'm going to plug in, here's our general form. I'm going to plug in 9 for y and -3 for x. Then I'm going to come up with the second equation using this one. So I'll call this y2 and this y1. So this is my y1, and I'm going to come up with a y2. Okay, so my y2 is going to be, if I plug in 1 for y and 2 for x. So now I have a system of equations that has 2 unknowns, 2 equations and 2 unknowns. So because this is multiplication here, what we're going to do is, I want to get rid of these a's so I can solve for b. So what I'm going to do is, I'm going to divide equation 1 by equation 2. I'm going to take 9 is equal to a times b to the -3rd and divide it by 1 is equal to a times b squared. When I do that, I get 9 divided by 1 is 9. A divided by a is 1, and that's how we get rid of that a. And then b to the -3 divided by b to the second is going to be b to the -5, because when you divide like bases, you subtract your exponents. So if I have b to the -3 over b squared, I take -3 and subtract 2, and I would get b to the -5. So now I have this equation. I have b to the negative 5 is equal to 9, and I can go ahead and solve for b now. So I would raise both sides of the equation to the negative 1/5. You want to raise it to the reciprocal so that you can get rid of that exponent. When you raise a power to a power, you multiply your exponents. So if I take negative 5 times negative 1/5, that's going to give me b to the first. And then I have 9 to the negative 1/5. Now, I personally don't like having negatives in my exponents, so I'm actually going to rewrite that with a positive exponent by flipping that 9 upside down. I'm going to get rid of that negative exponent by rewriting it as 1/9 to the 1/5. Okay, so now we have b. So I have my equation y is equal to a times b, which we said is 1/9 to the 1/5, all raised to the power of x. So now I have to find a. So I'm going to plug in a point again for x and y so I can solve that for a. So I'm going to plug in the 2 and the 1. You can pick the negative 3 and the 9 if you want. You should still get the same answer. So I'm going to plug in 1 for y, and I'm going to plug in 2 for x. So that's going to give me 1 is equal to a. If I raise a power to a power, I have to multiply. So if I take 1/5 to the power of 2, that's going to give me 1/5 times 2, which is 2/5. So I'm going to have 1/9 to the 2/5. Now I'm going to divide both sides by 1/9 to the 2/5 so I can solve for a. So when I take 1 divided by 1/9 to the 2/5, I'm going to get 9 to the 2/5. So my final answer, now that I found a, is going to be y is equal to 9 to the 2/5 times 1/9 to the 1/5 x, which I can write as x over 5. So this one takes a lot more work, and you have to be really comfortable with your exponent rules, as you can see that you use them quite a bit through here. So in the module for chapter 6, I have some optional videos in there if you want to go back and review your exponent rules so that you can become more comfortable with this. You can go watch some of those videos to do that. So those aren't a requirement, but I would definitely look at those if you haven't used your exponent rules in a while.